So today we have a 2007 Suzuki XL-7, I believe it is, all-wheel drive. The customer complains that the MIL is on, or was on. Some other warning lights related to the ABS were on. All-wheel drive was disabled apparently. Has a problem with the heater not switching back to defrost if you take it off defrost. And I believe that was pretty much it. When he brought it here today, the only light on is the tire pressure monitor. So I've already scanned this thing. We'll have a look at the codes. Well, the other thing the customer had noted was that when there was times when the tach wasn't working as well, which I thought was odd. He did not say that he had a problem starting it or experienced extended cranking time. So in the engine control computer, we've got a P0300 301 and a P0496 evap system flow during non-purge. So maybe the purge solenoid is sticking, and I suppose that could cause an overfueling event, but we'll have a look at the misfire data. C0460 steering position calibration data set not programmed, and left front wheel speed sensor circuit fault. That could then disable the anti-lock brakes, I'm sure. BCM has a lost communication with the remote function actuation. And here are some codes related to the airflow control dual zone feedback circuit short to battery. 3779, 3782. I suspect that's related to the system not blowing on defrost correctly, and then of course the tire pressure monitors are all present. Interestingly, the only code in the OBD2 side is a P0496. So we're going to look at freeze frame data in the engine control computer, hopefully related to the last emission related DTC. Hope that's a misfire code and not the evap code. No, damn it, it set the last emission related DTC that stored the freeze frame as P0496. It was in closed loop. Long-term fuel trims look normal. Short-term fuel trim, nothing wild there. But of course it doesn't have fuel tank pressure in here. So we'll have to look at what causes those codes to set. So here's the troubleshooter information in the snap-on scanner for P0496. So the DTC tests for continuous intake manifold vacuum flow to the evap system. The control module seals the evap system by commanding the evap canister purge solenoid valve closed and the evap canister vent solenoid valve closed. The control module monitors the fuel tank pressure. We determine if vacuum is being drawn on the evap system. If vacuum in the evap system is more than a predetermined value within a predetermined time, this DTC sets. In other words, smoke and mirrors. Observe the freeze frame failure record vehicle mileage since the diagnostic test last failed. May help determine how often the condition occurs. And apparently runs a test when it's first started and meets the conditions. Well, that's not much help. Well, I'll have a visual inspection under the hood. So with the engine cover removed, we can see the purge solenoid. You can hear it clicking now, and there's actually vacuum going through it right now. So I'm going to unplug the electrical connector and see if we lose vacuum. I'm going to have to set this down. So I've got the electrical connector unplugged, and it's showing vacuum in the tank. I'm going to bleed it off. So I bleed the vacuum off, and the purge solenoid is obviously leaking. And we bleed it off one more time. So that would account for the purge detected during non-purge event, but I don't know about the misfire. This thing's only got 142,000 kilometers on it, so I trust the spark plugs are all original. It's certainly not misfiring now. So no explanation for the customer's complaint that the tach was dead, because the tach is networked. It says the PCM determines speed of the engine and sends a CAN signal to the BCM. The BCM indicates the engine speed to the instrument cluster via Class 2 serial data. So it will default to 0 if the PCM detects a malfunction in the engine speed sensor, which we would expect to cause a longer than normal cranking time and probably a crank sensor code. And also, if there was a communication problem between the BCM and the PCM, or the IPC didn't get Class 2 communications, but none of those had set codes. So I think we're going to order up that canister purge solenoid, because we know that it definitely needs that. I've cleared all the codes and we're going to give it back to the customer. I've also looked at this left front wheel speed sensor problem. It's currently working. I don't see anything wrong with the wiring. Most of this stuff on this vehicle looks like a GM. I'm very suspicious that it is a lot of GM parts in this Suzuki, but nevertheless, I'm going to take it for a road test, monitor the wheel speed sensor signals, and wiggle the wires on the left front speed sensor and see if I can get it tacked up. So the HVAC system had a code in history B3779 and another one B3782. They aren't current, and they have to do with mode door. So I'm going to try the calibration process. I've cleared the codes, and I'm going to try this calibration process. It says it can take up to 40 seconds. Do it with the key on. Well, I guess there's not going to be any data while we're watching this. It says up to 40 seconds, so we'll watch this and see what it does. It says if you change the HVAC module, the control head itself, you do not have to do the calibration, as it will automatically do it as soon as you start the vehicle. I'm hoping this will actuate the mode doors, run them to their limits, and then see if there's a problem with one of them. Well, that's like 30 seconds. Not much happening. Well, that could be a bad sign if it's having difficulty moving one of the mode doors. I would expect it to come up and say done, or process failed, or something like that, but not sitting here in limbo. Well, that's been like a minute. Okay, we're going to exit, and we're going to go and see if there's any codes. Current, nothing. History, nothing. Now, he said that he had a problem with the defrost door. So, mode door position, rear defogger door, rear defogger request, blower motor, left temperature door. Okay, let's go with the mode door. Outside temperature minus 40. Well, that's not right. Now, is that a misreading data parameter on Snap-on's part, or is there a problem with the outside air temp sensor? Usually when a temp sensor is open or out of range, it shows as minus 40. I'll change the list. I want to give this HVAC door position list would be the right list to have up here if we're going to command the doors to move. Mode door actual counts. Mode door commanded counts. Alright, let's try turning it on. So it looks like it's commanding it to 255, and it's reached 226, and commanding it all the way the other way, off, commanding it to 0, and it's not moving. Well, we'll have to look into what causes that malfunction. It's probably a mode. Oh, there it goes. Now the customer said that when it was cold, if he switched it off of defrost onto vent or floor, he could never get it to go back. Even still, it's not going. It's commanding it to 0, but it's only going to 54 counts. Now I wonder how this one actually determines the position. I wonder if this one actually has a potentiometer in it, or if it's using commutator bar current fluctuations. We'll have to look at the schematic. So these diagrams look like GM. They're using mode actuators similar to GM. You can see the mode actuator has an electrically reversible motor with a potentiometer in it. So I suspect that the potentiometer is failing in the actuator that controls the defrost, which would be the mode actuator. The recirculation actuator, temperature actuator look like they're the same schematics, but who knows if they're the same part. We'll have to see what's involved in changing one. So this mode door is working properly now. It's on defrost, switching it to floor, and it's now blowing on the floor. Put it on the vent. It's blowing out the vents. I suspect that the plastic gears that are actuated by that motor are binding in cold weather. I couldn't find any TSBs on it. I was right about this being GM. This is built in the Cami plant in Oshawa, I believe, the same plant that builds the Terrain or Equinox, one of those two, side by side. That's why it looks like a lot of GM buttons and stuff. This is exactly the same controls you typically find on a GM vehicle. Even the steering wheel looks like a Chevy with a Suzuki logo. Oh well, we're going to discuss the potential repairs with the customer.